बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला सय्यिदिना मुहम्मदिन व अला आलि सय्यिदिना मुहम्मदिन व बारिक वसल्लिम। रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Umar Farooq. In today's lecture, I'll talk about some reactive chemical species, for example, ions, molecular ions, and free radicals. In your textbook, these are discussed under the heading of chemical species. लेकिन chemical species तो और भी हैं, जैसे atoms, molecules, मगर यहाँ हम उन species की discussion करेंगे which are relatively more reactive. That's why I wrote reactive chemical species. Of these chemical species, I have discussed ions in lecture number 2 and 8. So I won't force you to listen to me third time, and you may skip this and start from the next by bringing your seek bar at 5 minutes. An atom is a neutral particle overall, as it has equal number of protons and electrons. But if this balance is disturbed, it acquires some charge. Loss of electron creates a positive charge on it, while gain of electron creates negative charge. And this charged atom is called ion, which is defined as an atom having positive or negative charge is called an ion. So there are two types of ions: positive ion, also called cation, and negative ion, which is also called anion. Let's discuss them in detail. Positive ion. An atom having positive charge is called positive ion or cation. A positive ion is formed when an atom loses one or more electrons. This is shown by general chemical equation in which a neutral atom A loses an electrons and acquires an positive charge. For example, hydrogen atom loses one electron to form unipositive ion. Sodium atom loses one electron to form unipositive ion. Similarly, magnesium atom loses two electrons to form dipositive ion, and aluminium atom loses three electrons to form tripositive ion. Negative ion. An atom having negative charge is called negative ion or anion. A negative ion is formed when an atom gains one or more electrons, which is shown by this general equation in which a neutral atom B absorbs an electrons and acquires n negative charge. For example, chlorine atom gains one electron to form chloride ion, oxygen gains two electrons to form oxide ion, and nitrogen gains three electrons to form nitride ion. Positive ions are usually called positive radicals and negative ions the negative radicals. Note that the cations having group of atoms are less common, for example ammonium and hydronium. But there are many examples of anions having group of atoms like hydroxide, permanganate, dichromate, sulfate, carbonate, phosphate, acetate, etc. Let us now differentiate ions from atoms. An atom is the smallest particle of an element, whereas an ion is the smallest unit of an ionic compound. An atom may or may not exist independently and can take part in a chemical reaction. You are very well aware of this fact that only the atoms of noble gases exist independently, whereas the atoms of rest of the elements do not. On the other hand, an ion cannot exist independently and is always surrounded by oppositely charged ions. An atom is electrically neutral due to the presence of equal number of electrons and protons. On the other hand, an ion has a net charge on it, either positive or negative. Next in the list is molecular ions. So, a molecular ion is defined as a molecular species having positive or negative charge. For example, CH4 positive, He positive, N2 positive, etc., which are formed from the molecules methane, helium, and nitrogen respectively. Note that cationic molecular ions are more abundant than anionic ones. Now, a question arises, how are these molecular ions formed? So, let's talk about their formation. When a beam of high energy electrons, for example cathode rays, is bombarded on the molecules of a substance in vapor state, an electron is removed, and as a result, we get a molecular cation. It is represented by this general equation, in which M stands for molecule, in gaseous state, of course, and E negative is for high energy electron. M plus is the resulting molecular ion. Along with two electrons, one is attacking and the other is knocked out from M. Let's see the impact of bombardment of electron on a molecule. This is the molecule M to be attacked by this electron, and the impact of this attack produces molecular ion M positive and two electrons. One is attacking while the other is knocked out from the molecule M. Hope you got my point. Let us now differentiate a molecular ion from a molecule. As you know, students, a molecule is the smallest particle of an element or a compound which can exist independently and shows all the properties of that substance. Whereas a molecular ion is a molecular species having positive or negative charge. Usually, a molecule is formed by the combination of atoms. But remember, students, single atom can be a molecule. For example, the atoms of noble gases exist in the form of monoatomic molecules. On the other hand, a molecular ion is formed by the ionization of a molecule. A molecule is always electrically neutral, whereas a molecular ion has a net charge on it, either positive or negative. And lastly, a molecule is a stable unit. On the other hand, a molecular ion is a reactive species. And last in the list of reactive chemical species is free radicals. So, a free radical is defined as follows. An atom or a group of atoms possessing odd number of electrons or unpaired electrons. I will explain the term odd number or unpaired electrons on next slides. It is represented by putting a dot in the superscript of the symbol, for example, H dot hydrogen free radical, Cl dot chlorine free radical, and CH3 dot is methyl free radical, etc. Now, a question arises about their formation. So, free radicals are formed by the homolytic cleavage of the covalent bond between two atoms when they absorb heat or light energy. This process is known as homolysis. You can also pronounce it like homolysis. Homo means same or symmetrical, and lysis means breakdown. For example, chlorine molecule decomposes or breaks up into 2 Cl dot in the presence of sunlight. Similarly, methane molecule CH4 in the presence of sunlight breaks up to form methyl free radical and hydrogen free radical. I'll now elaborate these two equations on the next two slides. Cl2 molecule forms 2 Cl dot in the presence of sunlight. The bond between two chlorine atoms is covalent. The solid line between two chlorine atoms represents a shared pair of electrons. This is the incident photon of light, which may be visible or UV light. And as a result of this bombardment, the bond breaks and each chlorine atom carries its electron back towards itself, which is represented as a dot over its symbol. These are free radicals of chlorine. Note that each of these species contains 3 electron pairs, whereas this electron, you see, this is unpaired, and if you count the number of valence electrons on each chlorine atom, it is 7, which is an odd number, of course. This implies that Cl dot possesses odd number of electrons, due to which one electron is unpaired. I hope you understand. And its octet is incomplete, you see. So this is how 2 chlorine free radicals are formed. And this is to be noted that a free radical is extremely reactive species, as it has tendency to complete its octet. The other reaction can be explained likewise. That is, a molecule of methane in the presence of sunlight breaks up, giving 2 free radicals, methyl free radical and hydrogen free radical. Now, this is the structural formula of methane, and this is its electronic formula. Now, the photon of light is bombarded on methane molecule, and say this covalent bond breaks up. Then both carbon and hydrogen possess an unpaired electron, and ultimately we get the methyl and hydrogen free radicals. Let us now differentiate free radicals from ions. As you know that ions are the atoms or group of atoms which bear some charge. On the other hand, free radicals are the atoms or group of atoms that have odd number of electrons. Secondly, ions exist in solution or in crystal lattice, whereas free radicals can exist in solution as well as in air. The formation of ions is not affected by the presence of light. On the other hand, free radicals may form in the presence of light. With this, we have finished our today's lecture in accordance with your textbook. To have deeper understanding of free radicals apart from your textbook, please concentrate for another 7 minutes. So, a radical is a species carrying odd number of electrons, whether it is neutral, positively charged, or negatively charged, and is more reactive than neutral atom or molecule. In routine, we use the term radical for every ion by convention or tradition. यानी केमिस्ट्री में हर आयन को रेडिकल कहने की एक रिवायत है, ख़ास तौर पर हमारे बर्रे अज़ीम में यानी सब कॉन्टिनेंट में, जबकि हकीकत इससे बिल्कुल मुख्तलिफ है, और वो ये कि हर आयन रेडिकल नहीं होता। सिर्फ वही आयन रेडिकल कहलाएगा जिसमें ऑड नंबर ऑफ इलेक्ट्रॉन्स पाए जाएं। I repeat, we must call an ion a radical if and only if it contains odd number of electrons. This implies that neither all the radicals are ions nor all the ions are radicals, कि ना तो तमाम radicals ions होते हैं, क्योंकि radical तो neutral भी होता है। इसी तरह तमाम आयंस का रेडिकल होना भी लाजमी नहीं है। असल में रेडिकल की इस्तिलाह ऐसी चीज़ या शख्स के लिए इस्तेमाल की जाती है जिसका मिजाज इंतहा पसंदाना हो, केमिस्ट्री की ज़बान में जो अनस्टेबल हो या जिसकी स्टेबिलिटी कम हो, इसीलिए वो ज़्यादा रिएक्टिव होता है, क्योंकि reactivity is inversely proportional to stability. And note that both ions and free radicals may consist of a single atom or a group of atoms. Let's talk about types of radicals. Broadly speaking, there are two major types of radicals, radical ion and free radical. A radical ion is a charged species bearing odd number of electrons, whereas a free radical is a neutral species bearing odd number of electrons. यानी रेडिकल खा चार्ज स्पीशी हो या न्यूट्रल स्पीशीज, ऑड नंबर ऑफ इलेक्ट्रॉन्स होना लाजमी है. A radical ion is formed by one of the following two ways, that is, either by complete transfer of electron from one atom to another or heterolytic cleavage of a covalent bond. On the other hand, a free radical is formed by homolytic cleavage of a covalent bond. On the next slides, I will explain the formation of radical by each of these methods. Method number 1 of the formation of radicals by complete transfer of electron from one species to another is explained with the help of an animation. The atom losing its electron becomes cation, whereas the other one becomes anion. And we, the people of subcontinent, usually call every cation a positive radical or cationic radical, and every anion a negative radical or anionic radical by convention, and do not even bother to check whether its electrons are odd or even in number. हाँ, अगर नंबर ऑफ इलेक्ट्रॉन्स ऑड हों फिर इन्हें ज़रूर पॉजिटिव या नेगेटिव रेडिकल्स कहिए. In rest of the world, they are simply called cation and anion. ये गलत इस्तेलाह सिर्फ हमारे बर्रे अज़ीम की किताबों में मिलेगी आपको, और इसीलिए इम्तिहानात में भी पूछी जाती है. मैं इसीलिए वजाहत कर रहा हूँ. नेगेटिव और पॉजिटिव रेडिकल्स के लिए हमारे यहाँ दो और टर्म्स इस्तेमाल की जाती हैं, और वो हैं एसिड एंड बेसिक रेडिकल्स. You know that a salt is a combination of a cation and an anion, and is usually formed by the reaction of an acid with a base. For example, when NaOH base reacts with HCl, which is an acid, they form a salt, sodium chloride, and water. In this salt, the cationic part, that is Na, comes from the base. That's why it is called the basic radical of the salt. Whereas the anionic part, the Cl negative, comes from the acid. That's why we call it acid radical. Method number 2 and 3 of the formation of radicals is by bond cleavage or bond breakage. A covalent bond cleaves in two ways depending upon the electronegativities of the bonded atoms, and they are homolytic cleavage or homolysis, and second is heterolytic cleavage or heterolysis. During homolytic cleavage, each bonded atom withdraws its own electron back, which is shown by putting a dot over its symbol. Homolysis occurs if electronegativities of bonded atoms are either same or slightly different. And what is electronegativity? Electronegativity is the ability of an atom to attract the shared electrons. The electrons are more attracted to the atom with higher electronegativity. On the other hand, during heterolysis, more electronegative atom withdraws not only its own electron but other atoms' electron as well, and by doing so it acquires negative charge, while the less electronegative atom acquires a positive charge. Let me now elaborate this with the help of a diagram. Consider a molecule AB in which atom A and B each shares one electron, and this is the shared pair of electrons. Let's first discuss homolytic cleavage of the bond between A and B. Suppose electronegativity of A is approximately equal to the electronegativity of B, then bond cleaves in such a way that each atom A and B carries its electron back towards itself, which appears as a dot over their symbols. For the sake of simplicity, we do not write electron pairs with their symbols. So these are free radicals of A and B, and these are their unpaired electrons. Now, if the electronegativity of A is less than that of B, then heterolysis occurs. That is, the atom B carries the full electron pair towards itself and deprives atom A of electrons. This results in the creation of positive charge on A and negative charge on atom B. Hope you got this. In short, we can say that any species carrying a positive charge with odd number of electrons or a negative charge with odd number of electrons or no charge but with odd number of electrons can be called as radical. यानी रेडिकल कैटायन और रेडिकल एनायन में जो चीज़ उन्हें रेडिकल का दर्जा अता करती है वो है उनमें मौजूद ऑड नंबर ऑफ इलेक्ट्रॉन्स जो हर आयन में नहीं पाए जाते हैं. So an ion will be a radical if and only if it contains odd number of electrons. This implies that neither all the radicals are ions nor all the ions are radicals. Hope you understand. If you have any questions, please do write in the comments below. Thank you.